Get started. So, do you guys remember what did we learn in the last class? By any chance? Hey, Anjika. Okay. Do you guys remember what did we learn in the last class? We started with unit circles.
I think it was radians and degrees.
Radians and degrees, and we learned about the unit circles. Correct? All right. So take 10 seconds to recall what did we learn while I'm getting the markers. All right, everybody with me? So, does everybody in the class know what is unit circle? The basic concepts.
So I have a vague idea, but I don't really know what unit circle is.
Okay, so let's quickly look at it, because what we're going to talk about is sine, cosine, and tangent identities. That's the plan for today. So to be able to go down that path, we certainly need to have a very clear understanding of what is unit circle. Come on. So this is a circle, as you can see on the board. Is it visible to you guys or not?
Yes,
Yeah.
I can see.
Okay. Okay, this will be better. So this is a circle, and when we talked about unit circle, we tried relating our understanding of the circle with the basics of trigonometry. So if you look at the circle, you can break it down into 4 equal parts, like a pizza divided to 4 equal pieces. And if you have to find out, let's say, the coordinates of this one. So if you imagine this like a coordinate plane, this is your x-axis, this is your y-axis. If you have to find out the coordinates of this plane, this point, let's say this is point K. If you have to find out the coordinates of this point, do you guys remember what did we find? What did we do? This is my origin, and I will join this point. So this makes an angle theta with this x-axis. So do you guys remember what would be the coordinates of this point when it makes angle theta? The x coordinate will be cos theta, and the y coordinate will be sine theta. Or I will say, okay. So let's quickly look at how did we find it in the previous class. So let's say this is your radius r. This is r. What is the value of this guy? So if this is theta, let's say this is let's say some random number, let's say L. Okay, so here sine theta will be equal to L divided by R. Agreed?
Yes.
Cos theta will be equal to, let's say this is L. I'm not saying this part from here to here. Let's say this is let's say this is A and this is B, so that we can relate that with the right angle triangle. This is what we have done is, this is the point on the perimeter. We are trying to find out the coordinates of this point. So what did we do? We have drawn a perpendicular on this line, and we are saying this length is B and this is A. So with it, and this is anyway the radius of the circle. So here if you say sine theta will be A divided by R, and cos theta will be equal to B divided by R. Is this part clear so far?
Yes.
Yeah. So that means value of A will be equal to R sine theta, and value of B from here, value of A from this equation will be A equal to R sine theta, and value of B coming from here will be R cos theta. Do you guys agree?
Yes, sir.
So now what is A? A is this height, and what is B? B is this from here to here. So if you visualize this as a coordinate plane, what will be your x coordinate? This part, right? Which is B. B is nothing but R cos theta, R times cos theta. And what is your y coordinate? Nothing but A. This is your x and this is your y axis. So what is your y coordinate? This is A. A is nothing but R sine theta. Yeah. So that is why I was saying, if you look at a unit circle, meaning circle like this, and you are trying to find out the coordinate of any particular point on the perimeter, that will be R times cos theta will be your x coordinate, and R times sine theta will be your y coordinate. And again, you can visualize this like this is your x axis, this is your y axis. With what you are doing is you are drawing a perpendicular and joining these. So this becomes your right angle triangle, and this is your theta. So if any point on the perimeter makes a angle theta with the center, your x coordinate, which is this, will be equal to R times cos theta, and y coordinate will be R times sin theta. Is that part clear so far?
Yes, sir.
Everybody? Dave, Rehan, Chris, Anjika?
Yes, sir.
Yes, sir.
Yeah, it makes sense.
Yeah. So this is what we learned basically in the previous class of unit circle. Now we are wanting to extend that to understand a little bit more about it and extend that information or knowledge or understanding to something called sine identities and sine, cos and tan identities. When we say identities, what is identity? What is my identity? I'm pretty much an old guy, wearing glasses, less hair, wear glasses, and I teach maths. That is my identity, right? Similarly, you guys have your identity, student, working hard to get a good score in SAT so that you can get to a good college. You have n number of siblings, you have certain age, that is your identity, right? Similarly, so in same sense, if she talks about sine, cos and tan identities, what we are trying to say is, we are trying to find out if this is my angle theta, this is an identity of this point. So what is the value of sine theta? If I play with this little bit, let's say today my age is, I hope you guys can guess my age, but yeah, I mean for the sake of transparency, let's say today my age is 48. What will be my age after 5 years? You know that, okay, 48 plus 5, 53. What will be my age after 10 years? 48 plus 10, 58. Yeah. Similarly here we are saying, when we talk about identities, so my identity, my base identity is something, and then I'm adding on the top of that. What was my age 15 years ago? 35, 33. What will be my age 20 years down the line? 68, if I'm alive till then, right? So here also, when you talk about identities, you're essentially talking about what is sine theta. What is the value if I do sine pi minus theta? What will be the value if I do sine pi minus pi plus theta? Similarly, what is the value of cos theta? What is cos pi minus theta? And again, I'll come back to that. what is the value of sine pi plus theta, and what is the relationship among them. So that is exactly what we are trying to do. My age today versus my age 5 years down the line, there is a relationship between these two. That is what we are trying to establish here. Is that part clear so far?
Yes, sir.
Okay. Rehan, Dev, Chris,
Yes, sir.
Ishwari, Anjika.
Yes.
And by now you guys have realized I don't let anybody sleep. I will keep bugging you guys, keep nudging you guys so that I get the confidence. That is my hidden motive behind bugging you guys, okay? If I keep reminding, keep asking, keep calling out names, the only thing I'm trying to ensure is everybody is able to follow what I'm saying. Alright. Now let's play with this. We are not studying a play. This is theta. Let's extend this line. Okay? Meaning, or let's look at if this is theta, let's reflect it. This is my x-axis, this is my y-axis. Let's reflect this line against the x-axis. What will it become? This. So it's like a mirror image. Against this being the mirror, so this will be theta as well. If this is angle theta, this will be also theta. But just because we know certain things, this is in the first quadrant, this is this quadrant. If this is the way we measure angle is like this, we go anti-clockwise. So this is theta. Here you come, it becomes 90 degree or pi by 2 radian. Come here, it becomes pi radian. 1.5 pi radian, 2 pi. If you travel in this direction, then it is negative. It's like a number line. Visualize this like a number line. This side you are going is positive, this side you are going is negative. Yeah? So here the problem is if I create a mess on the board, I have to redo it. So this is a circle. These are my x and y axis, and I am making angle theta here. And if I treat this as a mirror and reflect this line against the x-axis, I have another angle here. This will also be equal to theta in terms of value, but I will call this minus theta. Very simple funda. If you are going in this direction anti-clockwise, you will count this as positive. So theta, 2 theta, 5 theta, 10 theta, pi radian, 2 pi radian, whatnot. If you are traveling in this direction, meaning clockwise, this will be treated as a negative counting. Like you look at, or like you compare that with the number line. Is that okay?
Yes, sir.
So we will try finding out what is the value of sine theta. We will try finding out what is the value of sine minus theta. Similarly, if I reflect this line against the y-axis, meaning this is my mirror reflecting this, so this angle will be theta. Theta meaning from here to here. What I am saying is, this line, let's say I call this line as A, meaning O to A I am calling as A, I am calling this O to B as B, and O to C, let's say. This angle from here to here, how much this will be?
180 minus theta.
180 minus theta. For the premise of this particular topic, we will read the degrees in radians. Okay, so it will be pi minus theta. Agreed?
Yes, sir.
So here to here it is pi minus theta radian. Yeah. Now let's reflect this line against the x-axis again. So from here to here, how much it will be? So this is theta, this is equivalent to theta. So from here to here, this angle will be how much? Pi plus theta. Yeah.
Yes, sir.
So I'm first we are not trying to learn anything. I'm still playing. Okay. I have drawn something with my yeah, Ishwari.
Would pi be in pi isn't in degrees, so
Pi is, see, there are two ways you can measure an angle. I'm sorry.
would it be 180?
Yeah, pi radian is 180 degree. So basically, if you look at the entire circle, right? If you revolve, you make a complete revolution around the circle. This angle is how much? 360 degrees. Yeah, in degrees. There's another way you can measure that. That is called in radian. So this entire 360 degrees is equivalent to 2 pi. So if you talk in radian, it will be 2 pi radian. If you talk in degrees, it will be 360 degrees.
But can we use like radians and degrees as a notation?
You can. I mean, you have two options. Like there are two units of measurements, right? You can use metric system and you can use US customary system. Same way, you can measure the angles in two ways. One is in degrees, one is in radian. So when we start moving more towards trigonometry, that is where you will see we move away from the old school method of degrees to more towards radians. Yeah.
Yes.
So now here, only thing that we have done with all the circles that I have done on the board is we are trying to understand what is theta, what is pi minus theta, what is pi plus theta, what is minus theta. Okay, this is what we have seen so far. Okay, now let me do the janitor's job, do the cleaning of the board first. Okay, and again, no disrespect for the job, I was just kidding. Okay, now this is my circle or unit circle, whatever you call it. This is my x-axis, this is my y-axis. So this angle is theta. Okay. When I'm reflecting this angle against the y-axis, here to here it is pi minus theta. When I'm sorry for the interruption, I got my tea. Alright, so when I'm reflecting this angle against the x-axis again, this angle from here to here becomes pi plus theta, and this angle, if you look at it from here to here, it's minus theta in radian. So this is, we have just seen the four angles. Now let's go back to what we had learned in the previous class and find out the x and y coordinate of these points. So if this angle, let's say OA is theta, what will be the coordinate of this point? Let's say the radius is r. So r cos theta, and what will be the y coordinate? R sin theta. Correct?
Yes, sir.
What is the coordinate of this point? Let's say this is B. Again, this angle from here to here is how much? It is pi minus theta, correct?
Yes, sir.
So it will be R times cos of pi minus theta. Yep. And the y coordinate will be R times sine of pi minus theta. Everybody with me?
So I just have a question.
Mm-hmm.
So is there's the angle theta, right? And then you drew the same line on the other side. So are the angles equal? So if it is theta, why can't you just say negative r? Why can't the coordinate be negative r cos theta and then r sin theta?
So what you're saying, that makes complete sense. I'm just trying to go step by step, and then we'll try relating it. Okay. So
Okay.
again, we'll take reference of the coordinate plane and relate that. But right now I'm saying, we know that okay, any point on the perimeter, it goes by the angle that it makes with the x-axis in the positive direction. Take that, it will be r times of cos theta is the x coordinate, r times sin theta of the y coordinate will be the y coordinate. So here it's making pi minus theta, so I'm just replacing that angle with pi minus theta, and underlying principle remains the same. Yeah.
Yeah.
Now come to this point C. Here, what is the angle? Pi plus theta. So it will be r times cos pi plus theta, and my y coordinate will be r times sine pi plus theta. And again, there is nothing cryptic, nothing complex here. We are saying that what is my angle, and I will just use that angle to find out the coordinates. Yeah.
Yes, sir.
Anjika, Dev, Chris, Ishwari, Rehan.
Yes, sir.
Yep. Yeah, Chris.
Sir.
Wait, so you know the coordinates for A, B, and C. So what would the coordinate be for D?
I'm coming to that.
Okay.
So again, don't stress yourself out by overthinking. Simple thing that we have learned so far is, if I have a point on the perimeter, I will find out the angle, and my x coordinate will be r times of cos of that angle, and my y coordinate will be r times sine of that angle. And what will be the angle? I don't care. Yeah. So here, this is my D. So coming back to the previous question, it will be r times cos of that angle. Here we said, okay, if I am going anti-clockwise, I am counting it positive. If I am going clockwise, I am counting this as negative. So this becomes cos minus theta. Is that okay? And it will be r times sine of minus theta. That's fine? Nothing new?
Yes.
Now, let's look at some cool stuff. So, if you look at this point A and B, okay? If you look at this point A and B, okay? A is r cos theta, r sine theta. Look at it carefully, okay? My B's coordinates are r times cos pi minus theta, r times sine pi minus theta. Okay? It is just about observation, nothing complex here. Now, between A and B, what do you see? My x coordinate is here positive and here it is negative. Right, Ritika? This is relating back to the point that you were mentioning.
Yes, sir.
Yeah? So here, whatever is the value of my x coordinate, in case of A is positive, this is exactly the same value but negative. Similarly, for A and B, if you look at the y coordinate, which is this length here and this length here, both are positive, same value. Okay? So that means my y coordinates are same, here and here both. Yeah? And both are positive.
Yes, sir.
So if I am looking at point A and B, my y coordinates are same. What is my y coordinate? This and this. Yeah? So that means my y coordinates are same, meaning r of sine theta is equal to r of sine pi minus theta. R and R I can do tic-tac-toe. What I am left with? Sine theta is equal to sine pi minus theta. This is our first finding, our first interpretation. What does it mean? For any angle theta, the value of sine theta will be equal to sine of 180 minus theta. Now, how you can relate? Sine 20 degrees, if you know, you can find out sine 160 degree will be equal to same. Both will have same value. Sine 30 degree will be equal to sine 150 degree. Sine 90 degree will be equal to sine 90 degree. I don't have to say it again. Yeah. So basically what it means is, this is one of the identity that we found. Relationship between two sine angles. I will let you guys process this information while I'm taking a sip. Are you guys able to digest this?
Yes, sir.
Rehan, Dave, Chris, Anjika?
Yes, sir.
So, see, things might look cryptic, it's okay. I mean, I don't get tired if I have to say it again, okay? That's fine. But, first thing that we have derived from all this that we were doing for last 5-10 minutes, this was one of the findings. Okay? That sine of theta is equals to sine pi minus theta. That is what we found from this one, this unit circle. So remember, Ishwari, last time when we were discussing about unit circle, we were trying to figure out why do we need to worry so much about it. Trigonometry is very simple. So we know what is sine, cosine and tan, and we don't really have to get to a circle to figure it out. Now we are seeing the importance of that, right? As I said in the last class, that only thing that will be your takeaway from this unit circle is saying that any point on the perimeter of a circle, if you imagine this as a x and y coordinate, will be r of cos theta as your x coordinate and r of sin theta as your y coordinate. That is the only takeaway, and that takeaway we are applying here to get this thing derived. Are you guys with me?
Yes, sir. That makes sense.
Yep. See, I am so far sensible. And you guys know what my jokes are called, right? Those are called dad jokes. That's what my kids say. So whenever I go overboard and crack a joke, you can tag that as a dad joke. Alright. So this part we got it, right? Ritika, Rehan, everybody with me?
Yes, sir.
Alright. Now let's look at the other thing that we can observe. Sin theta equal to sin pi minus theta. That is one thumb rule we derived here, or we just saw it on the board. Now let's look at the x-axis part that you were saying, Ritika, right? Here my x-axis is positive, and here my x-axis value of here my value of the x-coordinate is positive, and my value of the x-coordinate is negative. Yes? That means whatever is the value coming from this guy's x-coordinate and this guy's x-coordinate, they are negative. I mean, they are same value but with a opposite sign. That means minus of this, minus a times minus equals a, right? That we all know. So that is what we are saying here. So let's look at the x-coordinate of B, A here. X-coordinate of A is r times cos theta. And x-coordinate of B is what? R times cos pi minus theta. Yeah? And we know that this value, if you multiply minus with that value, that equals this value. Correct? So we can say that r of cos theta equals minus of r cos pi minus theta. Correct?
Yes, sir.
So r and r tic-tac-toe. So what we see here is cos of theta equals minus of cos pi minus theta. So this is the second derivation. Okay. So we saw that sine of theta equals sine of pi minus theta. This was our first finding. This is our second finding. That if you are talking about sine theta, this value is always equal to sine of pi minus theta. If you are talking about cos theta, this value is equal to the negative of cos pi minus theta.
Yes, sir. Also, I have a quick question. So, the theta here is like in radians, right?
Yep.
What's the purpose of, does this still work in degrees, or why are we switching to radians?
See, I don't look a lazy person But sometimes it's okay to be lazy, right? I can say pi radian or I can say degrees. Let's say if I don't say pi, what happens? Everywhere you have pi, you'll replace that with 180.
Yes, sir.
Imagine how many places you will do so. See how voluminous this will look.
Mm-hmm.
So even if it doesn't make a logical sense, at least it helps you avoid wasting a little bit of ink.
Okay.
Yeah.
Okay.
So it's economical. I mean, if that is the only way I can convince you guys. Yeah. You're saving few fractions of a cent by using theta. Let's keep it there. Yeah. All right. So everybody got that right? That the saving that we are enforcing by using pi?
Yes, sir.
Technically, there is no difference. The only thing is, this is just another representation. And if I say 180 degree minus theta versus pi minus theta, that goes little smooth, that goes little fast. And I mean, you can see how much of a mess I'm creating by using theta versus how much I would create by using 180 degree. Yeah? I mean, sorry, 180 degree versus pi. Yeah. Alright, this part is okay. So, by doing all that we have done so far, there are two identities we realized, that sine of theta equals sine of pi minus theta. So tomorrow if somebody gives you sine of 168 degree equals, let's say, something, what will be the value of sine 22 degrees? No brainer. You'll just say it's the same. Yeah? Because this has become your thumb rule. Similarly, cos of theta is equal to minus of cos of pi minus theta. This was the second derivation we had. Yeah? Now, let's look at the other side of story. Meaning, when we go beyond pi, meaning this was my theta, and when we extended this line here, from here to here, this became pi plus theta. Yeah? What was my, so this was my A, this was my B, and this is my C, and this is my D. So for C, my x and y coordinates are r of cos pi plus theta and r of sine pi plus theta. Yeah? No issue with these things, right?
Yes, sir.
And this one is r of cos theta, r of sine theta, no issues. Now look at this point and this point. Here when you see your x, here in case of x and y coordinates both are positive. Here in this case, this is the third quadrant. If you visualize this as x and y axis in a coordinate plane, here your x and y, both the values are negative. Yeah? Correct?
Yes, sir.
So that means the x coordinate of this is equal to negative of x coordinate of this. Correct? Meaning r cos theta, which is the x coordinate of A, is equal to negative of the x coordinate of r cos pi plus theta.
Yes, sir.
Rehan, you have not spoken so far. I'm just trying to make sure that you
Yes,
are
sir.
with me. Yeah? Okay. Similarly, when you look at the y coordinate of this point is equal to negative of y coordinate of this, correct? That means r of sine theta, which is by point A, is equal to negative of r of sine pi plus theta. Yeah? I mean again, x coordinate you said we are talking about this line versus this line. This length versus this length. This is x coordinate. This is positive, this is negative. That's what I'm saying. R of cos theta will be my x coordinate of point A is equal to negative of the r of cos pi plus theta. Similarly, my y coordinate, which is this length, is equal to r of sine theta, and this is equivalent to the negative of this value. Yeah? So, this one tic-tac-toe, this one tic-tac-toe. What is the finding from this? Cos of theta is equal to minus of cos pi plus theta from the first one. And from this one you see that sine of theta is equal to minus sine of pi plus theta. This is the next thing that is derived. So, meaning if you are looking at cos theta, this one, cos of theta is equal to negative of cos pi plus theta. So basically if you are going beyond the semicircle, then this value, the cos of theta is negative of this one. Similarly, sine of theta is equal to negative of sine pi plus theta. Now you look at these two things together. Let's look at all the things that we have seen together so that you can relate. Sine, first thing we saw from here, sine of theta equals sine of pi minus theta. This was first finding. When it became plus, we saw it becoming sine of theta is equal to minus sine pi plus theta. Similarly, from here we found, meaning when we looked at this point and this point, we found that cos of theta equals to minus cos of pi minus theta. From this point we found that cos of theta equals minus cos of pi plus theta. Now take 10 seconds to process this, digest this, and see what is the interpretation from this. You see that when sine of theta you are doing within the semicircle, it's the same value, pi minus theta. But when you go beyond the semicircle, meaning you are adding pi plus theta, it becomes negative. So this and this are negative. In case of cos, this is immune to this problem. Be it in this quadrant, this point, or be it here. In both the scenarios, it's the same thing. So cos of theta is equal to minus of cos pi minus theta and equal to cos pi plus theta. Meaning, if you relate that in actual terms, cos of 30 degree is equal to minus cos of 150 degree, and is also equal to minus of cos of 210 degrees. 30 degrees by theta, pi minus theta 150 degree, and pi plus theta 210 degrees.
Yes, sir.
Make sense? So, summary is cos pi minus theta or pi plus theta are the same value. Well, in case of sine pi minus theta and sine pi plus theta, it inverses. Pi minus theta is positive, pi plus theta is negative. Meaning, value of sine, when it goes beyond 180 degree, it becomes negative. Yeah? That's what we saw. When it's below this thing, this remains positive. And that makes sense, right? Because your sine theta is actually talking about the y, on the y side of things. On the y-axis. So it will remain positive till you go here. As soon as you start traveling in this direction, that is when your y becomes negative. right? And that is why your sine theta value in the third and fourth quadrant is negative. Cos theta value in this quadrant and this quadrant will be positive, and this quadrant will be negative. I mean, these are different interpretations, right? I'm just trying to give you guys a correlation based on what we have seen.
Yes, sir.
Chris, Dave, are you guys with me?
Yes, sir. It makes
Yes,
sense.
sir.
Anjika, am I
Yeah.
helping you relate things? Yeah, are you able to relate what we saw just now? So, all that we have done so far, that just results into 4 statements. And see how easy it is for us to now relate. I mean, to be honest with you guys, I had studied these things long time ago when I was kind of going through it just before teaching you guys. That is when I thought, oh, this is something that we had learned long time ago, and I had kind of forgotten it. But this is a good thing. I mean, good way to relate it. These are the 4 lines that is a takeaway. Sine of theta equals sine pi minus theta. Sine of theta equals sine minus sine pi plus theta. Cos of theta equals minus cos pi minus theta. And cos of theta equals minus cos pi plus theta. So see, cos has got the immunization, okay, the vaccine. With be it minus or plus doesn't make a difference to it. Yeah. So this version of COVID versus this version of COVID both doesn't make a difference to it. Wherein sine is sensitive. It hasn't got the booster dose. Yeah. Yep. Can you guys relate it now? I could have just put these 4 lines for you guys to memorize, but that would have not made any sense to anybody. That's why we have, I would not say wasted, we have invested 35 minutes to talk about it. Yeah? Any questions so far? Moment of silence. Can I assume no questions? Everybody is clear?
Yes, sir.
Now let's go beyond this, and that is when we'll talk about tangent identities. Now, let's go back to the unit circle. See, something that we were not wanting to put much focus and emphasis on, which was unit circle. Now we are seeing reason or motivation for doing it. So now, forget about everything that we have done so far. If I have a point here, let's say this is my origin O and this is my point A. We all know that, okay, this is R cos theta and R sin theta. Even if you know it or you don't know it, doesn't make a difference at the moment, let's say. I'm just joining this point with this point without knowing anything about it. Okay? I'm just looking at this is a coordinate plane, this is my x-axis, this is my y-axis, and I don't know about all this fancy stuff. I just know that O and A is a straight line. Yeah? In a coordinate plane. Is that a good starting point? Everybody with me?
Yes, sir.
For a straight line, if I say, what is slope? In the simplest form, I mean, treat me like a 5th standard kid and teach me what exactly do you mean by a slope of line? Yes, Ritika.
The rise of the change in y values over the change in x values.
Yeah. That is, that still requires me to be a 8th grader, but yeah, I'll still take it. Yeah, Ishwari.
Is it the relationship between the independent and dependent variable, like the x and y axis?
Yeah, that is the same thing. Yeah, pretty much something like what Ritika said. Yeah.
Something you could say that is like how closer the line is to being 90 degrees.
Okay, I'll take that as well. Anybody else? Rehan, Chris, Dave, Anjika? Yes, Chris, go ahead.
Maybe like the rate at which like a line is changing, like increasing or decreasing, maybe.
Yeah, okay. Alright, so now let's say you guys have pretty much defined it. If I yeah, Shwari.
Is it tangent? Like on for a unit circle we would use.
You are considering me a 10th grader right now. When you say tangent,
Like, is it like in like did you mean like slope in a unit circle?
slope, I mean, I'm not talking about unit circle at all. I'm saying that this is my coordinate plane and this is my line by joining O and A. What do you mean by slope? Now,
Radius?
yeah. So let me spend a quick 2 minutes to kind of define it. Okay. Look at this. Let's say this is my line. Okay. This has some slope. This is less slope. This is more slope. Yeah. Meaning this is steep. This is shallow. This is shallower. This is flat. Yeah. So when you look at any line, that essentially tells you how steep or shallow it is. I mean, it's called shallow? I mean, steep or flat? Let's not say shallow. Okay. So if this is steep or this is flat, what is the difference between the two? When it is steep, that means for every increase of x, y is changing very rapidly. Here, this line versus this line. What is the difference? Here, for every increase of x, y is increasing this much. Here, for this much increase, y is changing by this much. Right? So, when you see a line being steep or being flat or the slope is more or less, simple thing is, what is the relationship between x and y, like you guys said? How fast my y is changing for every change of x. That is how we'll say it, the slope of a line, right? So here, in this case, your slope is nothing but is given a new name called tangent. Meaning, for x increase, how much y has changed? Meaning here, from here to here if you go, what is your increase in y? From 0 to this much. What is the increase in x? From 0 to this much. What is the value of your x here? R cos theta. What is the value of your y here? R sin theta. Yeah. So tan theta is nothing but your y by x. R of cos theta, sin theta, y is r sin theta, y r of cos theta. And then you will do tic-tac-toe and you will say that, sir, you are wasting my time by saying tan theta equals sin theta by cos theta. This is something that we have been knowing for ages now. Okay? But we are just correlating it here. That means now let's go back to the identity part of it. Now let's draw these lines. So this is my theta. This much is. We will not do all 4 quadrants. Let's do 2 of them. Okay. So this is my pi minus theta. Here, what is my? This is B. So this is R cos pi minus theta, R sin pi plus theta, pi minus theta. So what is the slope of this guy? Here again y value by x value. But look at this slope versus this slope. This slope is increasing slope, meaning for every increase of x, the value of y is increasing. Here what's happening? For every decrease of x, meaning if you look at negative side as an increase, so every decrease of x, y is also decreasing. So in this case, now let's look at what is the value of, so we know that sine of theta is equal to sine of, this is pi minus theta, and we know that cos of theta equals cos of pi minus theta. So here in this case, if you look at the slope of this guy, again value of y by x, so tan theta, which will be equal to, let's look at this one. Okay, tan pi minus theta will be equal to sine pi minus theta divided by cos pi minus theta. Yeah. Now you look at sine pi minus theta is nothing but sine theta. Cos pi minus theta is what? Minus of cos theta. So this equals tan pi minus theta equals minus of sine theta by cos theta, which equals minus of tan theta. So what is the correlation that you can draw from here? Look at this. When you're reflecting a line against the y-axis, what happens? Your slope inverses. Yeah. So earlier here your slope was, let's say, tan theta. Here it became, when you reflected this against the y-axis, your slope became inverse of what it was. So if your slope was, let's say, 2, now it became minus 2. Is it going down well or actually going down the drain?
It's okay, sir.
It's okay. Okay. No, I know that was a bad joke, but still, the only interpretation from whatever we have done so far is that tan of, or the slope of this inverses when you reflect it against the y-axis. So here it is a positive slope, it is a negative slope. Here slope says things are increasing, here it says it's decreasing. Yeah. That's the way you will relate. So I will let you guys play with the last part, meaning when you go for pi plus theta, in case of tan, what happens? You guys already know what is the value of sine theta versus sine pi plus theta, cos theta versus cos pi plus theta. So you will do sine and cos, sine by cos of that angle and see what that will be and how will you interpret that. It is not about memorizing this. This is about how do you relate things. How do you derive interpretation from what you see with your basic understanding of things? A quick summary of what we have learned so far. Sine of theta equals sine pi minus theta, no doubt. Sine of theta equals minus sine of pi plus theta, and we know why. Cos of theta equals minus cos pi minus theta. Similarly, cos of theta equals minus cos pi plus theta. So cos is immune, be it plus or minus. And then we saw tan of theta equals minus tan pi minus theta. Okay. So these are just the correlation. This will help you do your maths faster by relating things. These are nothing but I would not dare to call it a theorem, but these are the interpretations that we have drawn from what we have learned so far. Is it registered with you guys? I would want you guys to look at or play with unit circle and think about this scenario, pi plus theta. Also think about minus theta scenario. Play with that, okay? There's no assignment here, right? I mean, for this topic, you just have to look at what we have learned, how do you relate, and then how do you play with other angles that we did not talk about in this class. Because the underlying concept is the same. As long as you know the x and y coordinates, you can literally play with it. Yeah? That brings us to the end of the class. Any questions that you guys have before we say sayonara?